Hi folks, we're going to take a look at number 3 from the Unit 1 Lesson 6 homework. Okay, so here we're given this cubic polynomial and we're told that x minus 1 is one of its factors. But we notice here that the coefficient of x squared is unknown. Okay, so what does knowing that x minus 1 is a factor of this polynomial tell us? Well, one thing that it tells us is that if we were to divide this cubic by x minus 1, the remainder should be 0. Since it's a factor, it means it divides perfectly into this polynomial. So again, it means that the remainder has to be equal to 0. So what I'm going to do is I'm going to divide these two polynomials. Right? Now, since I'm dividing by a linear, I have the option of using synthetic division. You could certainly do this with long division, but it'll be much simpler with synthetic division. Okay, and let's see what happens. Okay, hopefully we'll get to the point where we can figure out what this p needs to be equal to. So recall how synthetic division works. We're going to work only with the coefficients. So here the coefficients are 1, p, the unknown, -1, and -2, and we're dividing it by x minus 1, so x minus a. So we're going to use 1 as our representative of the divisor. All right, so let's go through the process of synthetic division. So step 1 is to bring down that term. That's going to be the leading coefficient of our quotient. Okay, then 1 times 1 is 1. Okay, and now we're going to add these two to get the second coefficient. So that's going to give us p plus 1. Okay, now we multiply this to the 1 again. So p plus 1 times 1 is just p plus 1. Okay, we add these two expressions. So -1 plus p plus 1, well, the 1's cancel out, so I'm just left with p. And then lastly, p times 1 is equal to p. And I add these two expressions, so I have -2 plus p. Okay, and remember what we said. Because we know that x minus 1 has to be a factor, this expression, which of course represents the remainder, has to be equal to 0. All right, and so from here we know that -2 plus p has to be equal to 0. Hence, we can just solve p is equal to 2. And that's the only value of p that's going to make this work out. Okay, so just to recap here, number 1 was to realize that when a linear expression is a factor, it means it divides perfectly into the polynomial, meaning the remainder has to be 0. So we performed this division using synthetic division, remembering that that last expression at the end of our quotient represents the remainder, and we set this equal to 0. Okay, that's it for this one.